Cool. Thanks everyone for coming back for round 2 of our Intro to Docker series. It's Friday night and I know you have nothing better to do. I will make that joke every week until this is over. Anyway, so here I am finally able to share my entire screen. Had some glitches with Zoom last week, but it's working now, which is good because I have multiple windows that I need to switch between, and that was a big hindrance last time. So starting at where we kind of left off last week, we had VS Code running our Node.js project in containers, and the terminal connected to the container running Express.js and with Node installed. I've made a couple of tweaks since that one. Made a couple of edits to the Docker file. This Docker file, when it builds, it downloads all of the Node modules with npm install after copying the package.json file, which Node uses to manage dependencies. And I've set a default command to run the index.js script, which is exactly how we left it before. It reads a file from the disk using an environment variable to tell it where to come or where to read. And the Docker compose file mounts the shared volume between the ticker, which, as we recall, was just writing the date to that file every 5 seconds. And our current directory was mounted into the workspace, and that is what VS Code is looking for, mounting, so that all file changes that happen in the container also happen and get synced back down to disk. And also anything that happens on disk on my Mac gets synced into the container. Now, why did I make this change? Well, I want to be able to run a Docker build command. And this is, we didn't do this last week because we had no real reason to build containers. VS Code was hiding all of this for us. So what does a Docker build command do? It takes that Docker file, which I should open this one. It starts with the Alpine image that Microsoft has given us for use with VS Code specifically, but we'll just deploy it. We're not worried about optimization of containers yet. That can be a future topic. I can probably talk a whole hour about that alone. We're declaring that we expect an environment variable called ticker write file, and I'm defaulting it to /test. But in our Docker compose, we overwrote that to /mount/test. I'm copying the shell script to /ticker in that in this image, and then saying the default command is to run that shell script. So when I do a Docker run, this is the script that will run by default. Same here, index.js will run by default and start our web server. That's not listen. Okay, so let's run our Docker build. So first I'm saying -t, I want to tag the image that we build, which is basically just naming it. I'm just giving it a name. This first part is a repo that we have yet to create. So last week I mentioned how Docker is kind of mimicking Git commands. So here we're building an image and we're tagging it. So that's Git parlance. And we push it to a repo. So that's the URL for the repo. And then /ticker is the exact image name for this. I'm using the ticker.docker file. And my build context, which we briefly mentioned with Docker Compose last week, is the current working directory, which is all of this stuff that we see here.
Do you mind zooming in on that?
Oh, sure. Say when.
That's cool for me.
All right. Other trick with Zoom, you can also if you have the screen real estate, if you make it bigger, it will make things bigger. Okay, so we ran Docker build, and this went super quick because of caching, of layer caching. Each one of these steps is another layer that gets added onto the Docker image. So step one is pulling from that base image. I already had that base image downloaded last week, so it didn't have to pull anything. Layer two is just setting an environment variable. So that's just a single line of text essentially, and that is super quick. Copying in ticker.sh, it's a small file, copying it's quick. Here we also see it's like using cache for all of these layers, which means if you've already built that layer, it won't try to do it again. That's an optimization built into Docker, so it doesn't take any longer than it absolutely has to build these images. One other image that we have is this one, so let's build this guy, slightly different, but mostly the same, copying some files and then running some commands when we build. Let's call it express. We're going to pass in just the regular Docker file. I'm being explicit here, but you can remove this. By default, it's using a file called Docker file, but it can be anything. Again, I built this earlier just so I could save a couple minutes, because there's a couple things later on that will take a little bit of time, which will be good for questions.
That file, that
right.
Docker file, there's no file type?
Nope, it is the file type. So yeah, one thing with VS Code is anything that ends with Docker file will be parsed and syntax highlighted as a Docker file. So yeah, you can just call it Docker file, just like if you were using, like if you were compiling C programs or Go programs now, you can have a make file. A lot of other tools will have these like tool name file.
Got it.
So Docker just calls theirs Docker file. Let's see. So now the next thing that we want to do, following the kind of like Git flow, I guess, is to push. But I don't have this repo existing yet. So if you have your AWS account, now's a good time to load it up. Else, watch the recording and do it later. First thing, after we've logged in, we want to go to ECS. And then into the ECR section, we're going to go to repositories. I ran this all yesterday and blew as much away as I could find. So if anything shows up, that's why. But here I've blown away both of these. So we'll create a repository. As we see down here, I called it Express. So we'll do that. We'll ignore these options. Scanning is for security scanning, and tagging mutability is a future concept. So cool, we made that one. We also know that we need to make another one called ticker. So we shall do that now. And cool, we have both of them. And let's hop into this one. You see there are no images there yet. So this is another default thing that I'm being explicit with. Latest is the default tag name for this. So I'll just blow that away for now. We'll see that we are pushing this. So I'm going to do a Docker push with ticker. I'm going to get that started while the other one goes, just so we don't have to wait quite as long. All right. So now I'll make that bigger as well. 170. Cool. All right. So while these are pushing, the next thing that we want to do when we deploy a couple of Docker containers is we need to make a cluster in Fargate or in ECS, and then we'll use Fargate. So for that, We go into this cluster section. I'll do that here. And click Get Started. We get a nice diagram. I don't even have to make one. On the outside, we have cluster. Inside clusters, we have what are called services. Inside of services, we have a task definition. And then inside task definitions, we have container definitions. So a nice little pyramid or nesting doll, so to speak. And to be confusing, starting on the outside in approach, their website kind of takes you in the other direction, right? It starts at the inside and we work outwards. So I guess to start, we'll just do an Nginx base. We'll get to our images. It seems like they finished, but we'll start with Nginx. We'll edit this. Let's start with task definition name. Just call it ticker, because that's our little project name. Half a gig of memory is probably fine for running what we are doing. And quarter CPU, super small. These are all the defaults. Save that. We'll click next. Okay, so now we've automatically done two things. We've built the container definition and task definition. I'll show the JSON that this created for us in a second. But now we need to make a service. I want this service to be publicly accessible, so I'm going to make a load balancer. Load balancer port will be port 80. We could change that if we wanted, but I will leave this for now. We can also change some certain things like the health check port. And that's just what the load balancer is going to hit so often, like every few seconds, to make sure that the service is still up. If it's not, AWS will automatically kill it and bring up a new one for us. So we get a lot of automation for free using Fargate and all of these tools. So we'll save that. We'll hit next. I'm going to change the name to ticker. VPC and subnets. VPC stands for Virtual Private Cloud. So that's essentially just an entire network. So if you're familiar with IP addresses, I think it's going to give us like 10.0/16. So that's what, 65,000 private IP addresses, something like that. And that's all just for internal networking. And it's another security boundary in AWS. And then it's going to make a subnet or a group of subnets for us across all of the different availability zones, which are just data centers. So in Virginia, which is where I'm, what was that? No, okay. In Virginia, there's a few data centers scattered all around, and those are availability zones in AWS speak. And we're going to have one network for each one, or one subnet of the global VPC network for us. Okay, I'm going to click next, and we can review all of the stuff that we're going to do. So we're making a task to run Nginx, pulling from Docker Hub. It's running on port 80. The service is listening to the task port 80 and exposing that to the load balancer. So the service is what's managing the connection to the load balancer for us. And then we have a cluster that's just running all of the things and managing the networking overall. Let's click create. Apparently I still have a lingering task definition around. That's why it's starting at 5. So that's fine. We'll be able to blow that away and make something new. One thing that it didn't show us was it actually created a log group for us. These containers are going to be spitting out logs. They have to go somewhere. Otherwise, they're pretty useless. So CloudWatch, being so nice, or Fargate, being so nice, created a CloudWatch log group for us, named after the service. Now, there's currently nothing in there because we have no containers running, but they should be spinning up soon. We see that the VPC has been created. We got a couple of subnets out of it, and it made a security group. And currently it is spinning up our load balancer. Once that's done, we should be able to curl the endpoint and get basically a hello world out of it. While that's going, are there any questions, comments, or anything that you would like me to highlight more or less, I guess?
I was wondering, when they say cluster, underneath the hood, do you know, is it just like an EC2 instance, or how do they represent clusters here?
Right. I'm pretty sure they're using Firecracker for Fargate. So Firecracker, I'll bring it up real quick. Firecracker is an open source, battle tested, as they put it, way of running serverless computing resources. So this is essentially spinning up containers, but not really. They do some crazy things that I would love to see kind of included into Kubernetes land, but that's a whole other topic. But yeah, so this is running in a giant thing that we don't really get to see. Just like with Lambda, we don't get to really see which cluster this is. It's kind of like a virtual cluster. Yeah, we'll never really know under the hood what's going on, I guess, at least outside of their blog posts. But
yeah, so their expectations is like, this isn't a shared cluster. If something happens or something gets compromised, they expect that you're not going to be able to affect anybody else's cluster, right? Like, it's like a standard.
Right. Yeah. Yep. And I'll put this in the show notes, so to speak. I'll link to this. All right. Let's see. How are we going? Did it put us back to the first page when I refreshed? That's cute. Thanks, Amazon. I guess don't refresh the page. Cool. So we have our cluster, but we don't yet have services running, and I can't see the thing spinning anymore. Let's hop over to where that load balancer is. See how it's doing. So that's going to be in services EC2. And then load balancers on the left. Make that bigger. All right. All right. So I'll just give a brief look at load balancers while I wait for those services to be automatically deployed for us. That's one hell of a name. It was auto-generated for us, so we just have to kind of go with it. We'll copy the DNS name, because we'll use that in a second. All right, then we have a couple of listeners. So whenever you spin up a server, right, you have to tell it what port to listen to, and that's really what this is. It's saying listen for HTTP requests on port 80, and we're going to forward that to what they call target groups, if it loads. Thank you. Again, matching the same garbage random naming. And in the target group, so we have a listener on port 80 targeting. What will be in here will be a Fargate task, which let's check on that. I would expect that to be up soon. No? All right. Well, I'm just going to skip ahead to the part where I create my own task, my own service. I'm actually surprised this one. So here's the task that it created for us. So that's nice. We see that it's supposed to run Nginx. Always good when you find an AWS bug. This worked yesterday. Anyway, so So this is the nice fancy UI view, and it's kind of dense. I honestly don't like this view. I much prefer the JSON view. And yes, it's JSON, but I'm kind of used to looking at JSON every day, and learning how to read a different UI for me is just kind of a pain in the butt, especially when it's just all over the place like this. At least with JSON, I can search for things. So here we see the AWS logs group that it created for us in US East 1. You can see that it's mapping the Nginx port 80 to the container port 80 because Nginx is a web server just serving regular HTTP. Here's the CPU units that we saw before. This is just, you have to look in AWS docs to figure out what numbers these should be, but they're essentially multiples of 256. 256 is a quarter CPU. And then we have 512 of RAM, no volumes. Here we have the image that we saw earlier, Nginx latest. Easy enough. We're saying go to Fargate. And we have a bunch of labels. We'll blow those away later. All right. So go back to our cluster. All right, let's create one. Let's use that task that it just made for us. All right, we're going to launch in Fargate. We're going to use the ticker that we saw before, version 5. Let's call our service the same thing. We want to run just one of these. Don't know what IP that is. And we want 100% of them to run, so that's fine. We're going to do rolling updates just to be a little easier. You do get blue-green for free with Fargate. Blue-green is essentially, you have your currently running version, so we'll just call that arbitrarily blue. And if you want to make an update, it'll spin up a green. It'll be available, it'll become healthy, and then you can choose to switch which one is live. So you'll make green live, and then you can prune off blue when you want. Benefit of that is you can revert quickly. I don't think we care about hello world reverting, so we'll just leave it as rolling updates, and it'll just wait for the new one to be healthy and automatically prune off the current one. Tags, we don't care about tags right now. Next step, load balancer. We're going to do the one that it made for us and that it should have created for us. It's kind of fun. We're going to say use Nginx, even though there's only one option. You can run multiple containers, and we will. Let's see. Service discovery is optional. I might even just turn that off for now. Future topic. Okay. So here I'm setting it to that target group that we looked at before. I skipped past this because I thought it already had been set. It is not, so we'll do that. Oh. Set our subnets. What else did I miss? Do I have existing ones? I do. So when I ran through this first, it had set all of this up automatically. So now I am actually discovering the things that it had made for me, which I guess is good content anyway. So, all right, so this is the EC2 container service ticker ECS security group. Oh God, what a mouthful. Probably should have made these by hand. So what we can see is this is allowing ingress on all ports from security group 0E98. 0E98 is the security group that is attached to the application load balancer. So that's good. So that means our application load balancer can talk to anything with this security group. So we will use that. Got in our 2 subnets, got it in the VPC. Good. Okay. Nope, no auto scaling. Auto scaling basically gives us, if you're using a lot of CPU or memory or some other metric, you can automatically add more Fargate services or containers to handle the load. We're going to skip this for now. Don't DDoS me during the presentation. All right, let's create it. Service created. See, that's supposed to be quick. Now we'll view our service. Just want to make sure. Yeah, it didn't create any other ones. Cool. All right, so we'll go to tasks in that service, and we'll see that it is currently provisioning our task. And if we click into that, now it's in the pending state. Now, this is one thing that annoys me. I never get any logs here, ever. But if we remember from before, over here we had logs. Go back in here, and now we have logs. This is that Docker container ID that we had seen from last week. Really long random string of characters. Fine, we click into it. No events found. Oh, that's fun. Is it still pending? Yes. Oh, now it's running. And we have our log that it had started. And we're now getting those ELB health checkers. So that's the load balancer pinging every so often to say, hey, are you alive? Hey, are you alive? And we see that Nginx had returned a 200 SAS code. So it is saying, yes, I am. All right. So if it's still on my, it is, all right, on the clipboard. Let's hit that load balancer. Cool. And now we get the Nginx default homepage, which I can actually probably bring that up in the browser. Hey, it worked. We got our first container deployed, but we don't want Nginx. We want our stuff because our stuff's more complicated, has sharing volumes or shared volumes. So it's going to be cool. All right. So to do that, so we have our cluster, we have our service, and the service is looking at a task definition to tell it how to run things. So if we change our task definition, if we make a 6th version, it will automatically pick that up. Well, we'll tell it to upgrade to version 6, and it'll automatically do a diff and apply the changes. So let's go into our task definitions. Ticker 5, we'll click the big blue button, create a new revision. Same role is fine, Fargate's fine. All right. We're going to have to make this a little bit bigger because we're going to run 2 images in here. Let's walk through it this way. Oh, there's going to be a fun one. Okay, I want to show one little gotcha ahead of time. This cannot be changed. This is like the one thing that I really don't like about services in ECS. Any container that we call it must use Nginx. Now I could delete this service and make a new one, and I'll probably actually end up doing that, just so I don't have to have Nginx as the name of our Express server. So yeah, and we saw that it was pretty quick to make before, so we'll do that.
Just to clarify then, Nginx is exposing the container or the cluster, is exposing the cluster. It's not part of the container.
Nginx is what is running in the container.
Inside of the container, okay.
Yeah.
But the not our container, the container that Fargate provides. Is that fair to say?
Fargate is managing the container.
Okay.
So it spins up the Docker container and it makes sure it's running, and it does its checks. So yeah, I think it's actually /_/Nginx. Yes, so it's running this image off of Docker Hub. It should be running their latest image. All right, let's do this. Ticker Fargate 1 gig. We're going to remove that container. We don't want it. We're going to make our Express container, use our Express image. And I'm going to go back here. I'm just going to copy that. That's the image that we had pushed earlier. Thank you. Memory limits. 120 is probably fine. Actually, yeah. Port mappings. So we're running port 3000 in our container. So we'll put port 8000 or port 3000 here. Let's see, health check. So we can run a health check that's external, right? That we saw before with Nginx where it's hitting port 80. We can also run a health check in the container if we wanted. So this could be anything. We could do a curl like they're suggesting here. If we wanted to check that a database connection worked and we had the database tools installed in the container, we could run that command too. So that way you get a couple of levels of health checking, always helpful. But we're gonna skip that for now. I'm actually gonna remove this for now, I don't need it. All right, CPU. So here's where in the docs or their help text shows you that 1024 CPU units for every 1 CPU core. We'll do 256. We're going to leave the entry point and command blank because we have those set as defaults. And then environment variable. So if we go back to our Docker Compose, we see that we passed in this environment variable for where to write the file. So we'll add that. And the value will make mount test. Networking, we can pretty much skip all of this stuff. We'll want to add a volume in a second. Forgot to do that. All right, so we'll add this guy. We'll get this one started. We'll make another one for the ticker. That's the same place, just there. And we'll do the same thing. We'll tell it 256, so a quarter CPU, environment variable, ticker write file, /mount/test. So we can do dependencies between them. It's okay if they both start at different times. So in the Express one, we could say that we depend on the ticker script, but we'll skip that now. So yeah, we get these options, whether it started at all or if it's healthy. And we'll skip and add that. Okay, so now here, let's add that volume. We'll call it shared volume. How boring. Add that in, and it's bind mount. So what we'll have to do, go back into this at the bottom. Where was, oh, it went too far. Oops. And we said /mount/test in our environment variable. Right? So we want to make that, or /mount. Right? We don't want /test, that's the file name. So we'll mount the shared volume to /mount. How predictable. And yep, we're good with this, good with that. Let's update it. And we'll do the same for ticker. Oh, did I already do that for ticker? Whoops. There we go. Awesome. So now that we've done all that, we can also, if we really didn't want to use that UI, we can do this via JSON. Personally, I like doing it via JSON only. A lot of the AWS docs actually show you example JSON, so it's easier to kind of like copy and paste snippets. But also, if you ever want to automate the creation of this stuff, so maybe you want to do a proof of concept and just want to like get it deployed, you can do ClickOps essentially and go through the AWS UI and get it done this way, and then copy this JSON, and then you can use this in your automation. So if you want to make any changes to this, you have a good place to start because you know this will work once it's running. Then you can make your changes. I think this will be good. If it's not, we'll figure it out as we go. Sometimes I hope it doesn't work. That way we have something to debug. All right, let's hit create. So we have task definition version 6. If I go back here, we can create a service, which we did before. We're going to run it in Fargate. In the ticker cluster, we want 1 to run. Rolling updates. Wait, did I? Yep, and it's going to pick ticker version 6. Ugh, great. That's one thing I don't like about AWS's UI. You click next, it doesn't do anything. It's because you have a red box somewhere up above. Helpful. All right, application load balancer, doing all the same stuff. Now we only have one port exposed, so that's what it's defaulting to. We could have multiple. We could have multiple load balancers for the same service. That would be fine. You can have the same service, multiple target groups. AWS gives you a lot of ways of mixing and matching. So we'll do the same things that we did before. That one's actually. All right. Oh yeah, I disabled service discovery before. I will do that again. Essentially, all this does is put some DNS entry in Amazon's Route 53, which is their hosted DNS service. I'm skipping that for now. All right, let's see, I clicked it, nothing happened. Here we go. Yep. All right. Cool, skip auto scaling. Review. Pretty cool. Oh, I didn't do a security group. All right, let's see. Can I change that? Yep, here we go. No, it doesn't let me change it after I made it. That's annoying. All right. Well, I'll just do it the the fun way. So we'll go into the security group. Oh, it's allowing everything in. For now, that's fine. Don't really ever leave that in production. But all right. Fine. All right, back to viewing it. Okay, so we have this running. We shall open this in another window. We see that we have two containers running inside the same task definition assigned to the same service. So in kind of like Kubernetes world, you can kind of think of this as a pod, right? They're sharing the same persistent volume claim between these two. So, okay, now if we hop into CloudWatch, remember the old Nginx server was 42C. Express is 603. This way, if you kill and recycle the same container, they'll all be under the Express log stream, but with different container IDs. So here we see that it is starting. It is running on port 3000, so that's good. And ticker, we see that it's been writing dates apparently for a little while. That's cool. Nice. All right, let's see. So now what happens? Let me hit the same URL. All right, let's check our target groups. Okay, so we have, this one is unhealthy. Why? So now what we'll see, because it's unhealthy, is I should expect to see the container in the task definition get killed and rebooted. So let's where, let's see what our health check is. That's set to port 80. Oh, that's fun. All right, let's make a change. So I'm changing the Express image to run on 80 because, oops. I don't see the edit button for this. Dennis, you use target groups a lot. What am I missing? Ask the audience.
Ask the question again. I was grabbing a new beer.
Nice. Port 80 for the traffic port here. I want to change that. It's not letting me. What am I missing?
I think each target group has its own port, and I think you just have to create a new one if you want a different port.
Yeah, that's mildly unfortunate. Fine, let's do everything manually. Well, let's keep it, and then I'll just change that. Yeah, so here we can see that it's draining from the old one and spinning up a new one. Let's see. So I've pushed a new image with that, so it's probably going to start using. Oh wait, did I put 8,000 here? That's cute. All right, we'll do 80. Good on that. So now let's change our task definition, create a new revision. Yeah, click here. We're going to map 80. All right. Now if we see via JSON, good thing I checked. That's cute. So there you go. Sometimes the UI just doesn't do quite what you expect it to. All right, great. I love how these live demos always go slightly different than the way you practiced the day before, like just not creating the service by default. That's cute. All right, let's see. So now, the security group that the task should be, a service will be using is allowing ingress port 80 on all the things. The new image that I pushed is going to run on port 80 by default. We got to line all this stuff up, which is great. And let's see, here's my service. Here we see this is still using version 6, so we shall update that. So I fully expect that to fail. We'll do 7, which has our port 80 adjustment. It's going to make me change that. Yep, so there's that thing I was talking about earlier. You can't change the port. So we're going to update it. Yep, that's cool. Go away. We're going to make a new task or new service. Easy enough. Ticker, Fargate 7. Service name, ticker. We're getting good at this part. Oops. As I say that, I make a mistake. Oh, come on. I like how this doesn't get an asterisk for being required. Whoops. Load balancer. Yep, we want that one. Yep, we want express. Now it's recognizing 8080. Add to the load balancer. It's expecting 80. That target group. Perfect. Ignoring service discovery. Didn't pick subnets. All right. Didn't do that again. All right, that's fine. Oh, is it still? That's interesting. So the service is gone, but it still thinks that it's draining. I don't believe you. Where's my load balancer? All right, so let's check the targets. And we see that they are both draining. Wonder if I can force remove them. I'd rather not make a brand new one, because that'll take time. Cool. Well, maybe it is worth it. Any questions real quick? As I look to blow away half of this stuff and start with that part over.
What does draining mean?
Right. So it was in the pool. It was a target, right? So because I had the rolling deploy set up, which remember there were only two options, rolling or blue-green. It is draining all of the active connections to this instance of the task. And it won't change it, apparently, until all of them have finished draining. Now, the problem is I don't remember setting how long to drain. Like, what is the maximum amount of time? So that's kind of my concern. I hope it's not 5 minutes, because I really don't feel like waiting 5 minutes. But a lot of AWS services like defaulting to 300 seconds. So,
Okay, that makes sense. Thank you.
yeah. Yeah, it's trying not to have anything be down. But the problem is it's so conservative, at least by default, that it's down now, right? Like it's failing health checks. I don't care, right? I wish it went from unhealthy to just terminated, or at least gave me that option, because draining something that was never healthy doesn't really help, or at least rarely does. Because sometimes your health check, if you've kind of like done it wrong, is too simple. Like it just says, hey, is this static file there? Which is nice-ish, but sometimes that service gets really bogged down and your server just doesn't care enough to serve that one request, and it becomes unhealthy while it's still trying to serve real customers. So like I get why they want to go into the draining state, but it is mildly annoying sometimes. Let's see. All right.
George,
Yes.
if we're still waiting for that process, like,
Yep.
It's kind of like the issue going through right now. How much is this like a AWS annoyance versus like if we didn't have AWS and we weren't using Fargate, like, you know, this would be my mind's manual work for people, or, you know, there'd be other infrastructure involved. So like, is this kind of like a necessary evil, or is this, you know, again, if for people that haven't used Fargate before, it's like, is this still like an advancement above what they would do outside of AWS if they didn't have it?
Yeah, you'd have to end up writing your own automation for a lot of things, right? Like if you want to take down a service and just restart it, right? If you're just running your own server somewhere and you have a process running, yeah, you're free, take it down, go ahead. So Amazon knows building in like rolling deploys for you, and kind of like the general solution enters it into that draining state first. So if you wanted to have zero downtime deploys, you're going to have to put in some effort, or you can use off-the-shelf offerings, which may not always be exactly what you want.
Okay.
You know, the build
That's
versus
helpful.
buy kind of, you can do everything that you want if you build it yourself, but you spend a lot of money building it yourself. All right, let's, okay, so there are no registered targets here, so it is finally drained. Let me kill that. All right, let's do this. Great. All right, we should know pretty well how to do this now. Hopefully I don't miss anything, but I probably will. Good. Good. No at mesh, no service discovery, add to load balancer, pick that port, pick that target group. Good. Subnets, not going to forget this time. I got you. Now I'm going to pick this security group that I know worked the first time. It's allowing ingress on 80 and to the security group for all the things. Yeah. All right. Cool. Service finally created. Now we see this. We see our tasks. Cool. Now this is entered back into our provisioning state. We'll open that. Care about this. We see that they're both pending. We can see our environment variables that we passed in. See that these match. We're using our shared volume. We have a nice link off to CloudWatch, but that's okay because we saved it. Now look at all of the different things running. Our last event was, it's probably the old one. Cool, now we have two new ones. We see that the ticker is writing dates. And we are finally getting those health checker. So, because we know that we're returning 200s, it's probably healthy. So let's go back here. Hit this and cool, now we're getting our dates. And if I wait 5 seconds and run it again, we'll get new dates with slightly different timestamps. 53 versus 43 there, 58. And that is what we had running last week in Docker Compose using VS Code. And now we have it deployed fully in Fargate. So if you can write that down real quick and hit that yourself, go for it. Maybe I'll throw it in chat because it should be public to the world at this point. Go for it. Figure out what time it is in the most complicated way possible. So yeah, thanks for sticking through all of that troubleshooting, but hopefully that was somewhat helpful. At least you'll have the recording at some point to go back and say, he was getting these cycling problems. What happened to him? And you'll skip ahead through the hour of the video that happened. Nice. All right, so a little quick recap, and I will post the task definition JSON to the GitHub repo that I posted in the meetup page. Also, here, I'll just go to it here as well. Let's see, what did I call it? Go, VS Code remote containers. I'll put that in the Zoom chat as well. So you can see all of the code that's there. Pull it, do what you want. And yeah, I'll have that task definition uploaded. Let's see. So quick little recap. If I refresh this, I should see some images. I'll see a couple. We made a repository in ECR, which stands for Elastic Container Repositories. Amazon loves Elastic, so almost half of their services start with an E. We made a repository called Express. We pushed an image up to there. We also made one for ticker. We made task definition using some big JSON. We went through the UI. We looked at the JSON. We saw those things. We made a service in the cluster using that task definition that attached to a target group, which is attached to a load balancer, all so that we could make the most complicated way possible to tell us what time it is. Cool. Any questions about any of that? If not, that's cool. I'll be in Slack, rockdev or rock.dev. You can sign up for Slack that way. I heard somebody with something. What was that?
I was going to ask, do you have a perspective on how customers are using this or organizations are using this? Like we went through like a nice little demo ourselves,
Right.
but like at scale, what do you run into?
Let's see. So a couple of places I have worked in the past are using Fargate for a lot of internal tooling. Is definitely like the first place people are using Fargate, and that makes sense. That's generally true for a lot of new services, right? Let's use something internal to kind of assess, and then as it progresses on our radar, we'll eventually productionize it. So I'm seeing people run like CoreOS Claire in Fargate, right? Just spin up a container, run it there. We can send our container security scanning there. Even though Amazon has their own, some people want to run theirs. Or some Jenkins sometimes I've seen, which is kind of interesting. Just kind of spinning up dev tools. One company that I worked at in the past was in the middle of a big migration from running Docker services on EC2s, right? They had statically scheduled them there, and is now running their entire production workload for their main product in Fargate. And Mark, it is someplace that we have both kind of worked before, so you may know them. So yeah, that entire product, AWS. So if you're using that tool, everything's coming out of Fargate or SES, right? Those are the main services they use. So yeah, there's a wide range. I've seen some people running like Prometheus in there. They want that to be highly available and not have to worry about it. So they just run their Prometheus in there, and that goes off against their old school EC2 fleet. That way they don't have to manage it.
Would you say that like this feels like
Uh-oh, I think I lost you. Mark is switching input sources. I guess we can move to another question while he figures that out, unless he beats us.
Yeah. The headphones died.
Container, all right, Mark is chatting instead. Going to ask if this is like container orchestration light. Yes. If your organization is considering something like Kubernetes, I would recommend first looking at ECS and Fargate. Mark will hate me for saying that because he pen tests Kubernetes, so there goes his business. But no, I think a lot of organizations that are currently statically scheduling their Docker containers or considering a migration into Docker would definitely like to, or definitely should look at Fargate. Once you go through the UI and you figure out where the buttons are to click, it's pretty easy to use. You don't have to think about any servers ever. I mean, that's kind of the idea of serverless, right? So you don't have to patch the next time Heartbleed or shell shock happens, right? You have to just make a new container maybe and push that out to your fleet and be done, right? You change the task definition from version 6 to version 7, say service, use version 7 now, it'll do a rolling deploy for you. So customers that are coming from Elastic Beanstalk or running their own EC2s with their own AMIs in an application load balancer, as long as you containerize the application, you're there. And then at some point, if you really need to do custom resource definitions, persistent volume claims, pods, services, and all of that fun stuff, Kubernetes is waiting for you. Amazon has EKS, again, Elastic Kubernetes. So yes, I would call it or container orchestration light. But I also think that's a better fit for a lot of places. Fargate's not free though, right? You are paying for all of that managedness of it. Whether or not that's cheaper than hiring a bunch of people to manage your entire fleet of servers and keep everything up to date and build out tooling, that's up to you, but I think
Is there
that's
any
the value
cost
of it.
savings because it is serverless?
Actually, it costs more. So two options with Elastic Container Service. There's Fargate, which means you run no EC2s on your own. And then there's the EC2 option, where you run an ECS agent on your own EC2s, and then ECS will schedule against that fleet. You can run Fargate and EC2 alongside each other in the same ECS cluster. So you can get both. You can migrate from one to the other, right? That can be helpful. So yeah, with the EC2 option, you get a lot more control. You actually save a little bit of money, and then you pay it right back to your staff. So, but it depends. Do you want to be able to EC or SSH into the servers and do things? Yeah, you can't with Fargate. There are no servers to get into. One thing with Fargate, just because we're talking cost, you can save money with Fargate using Amazon's new savings plans. So with EC2s, you can reserve those instances for the next 3 years if you want, or 1 year, or whatever. But there's a new option called savings plans where you just say, I'm going to spend about $1,000 a month with you. And Amazon will say, thank you, please do. And here's a 10% discount. I forget what it is. That will apply to Fargate because you can't do reservations with Fargate. You have no servers. So there are some options. That's probably a long answer to those questions, but that's fine. Any other questions before I tear everything down and you guys cost me money with data transfer? I should check the logs. Oh yeah, I got all your IP addresses now. My long con. Anyway.
Sort of a question from last week. You said Docker was going to die and going to be replaced by Podman.
I don't know if I said that. I want it to.
I'm pretty sure you actually said it. So the question is, how's that going to affect things like this? And when do you think, if you can't do that now, when?
Right. So a couple things. Because Amazon has support for Docker, that's going to slow down any predictions like that. So I'll temper that a little bit. Podman, Builda, they're pretty much drop-in replacements for Docker, right? So if you do a build with those and then push to a repository, should work. I don't remember if those are compatible with existing Docker registries. I think they might be.
Yeah, it is.
Was that, Mark?
Yeah, it is compatible.
Perfect. So, I mean, if you're using that locally, you can push to the same repo and then Amazon things will just work. Fun thing with the way Fargate works, I think. So I don't believe Firecracker, which is what Fargate's using, is actually running Docker images. So in that regard, the Docker format in the repo is already just a data transfer object. So like I could use Podman on my Mac, push to this repo, and then have it pulled down by Fargate to be run in a completely different way. One future talk I kind of want to do with Docker is Docker without Docker. So for those familiar with CoreOS, about 6 years ago, they were bought by Red Hat. They made their own container format called Rocket, or RKT for short. they had a concept of a toolbox image. That toolbox, it would do a Docker pull, save it or export it, I can't remember, to a tar, untar the package to a folder, and then use systemd nspawn to spin up a container without Docker, using all of the things that were in your Docker image. And I think that's kind of what Fargate might be doing, like exploding the tarball that is the Docker image and then doing things with it. So yes, Docker could still go away and these pieces could still work because it's almost like an interchange format now. You can Docker save and import Docker images into tars to ship those tarballs to a server and then either load it back into Docker or systemd nspawn or do whatever you will. And I'm pretty sure Rocket and all those guys have different ways of converting Docker images into theirs. There's also the Open Container Initiative, which is standardizing what a container looks like. So that way there is no translation. So I would believe that it all still works, even if the Docker commands themselves become other commands. Mark, you know the most about Kubernetes, at least on my current view. I saw there was some chat about Kubernetes not using Docker by default. Is that a thing?
I have not heard that. They seem so embedded with Docker, and yet they all loathe Docker at the same time. So I've never heard of somebody. I've seen, obviously like GKE and things like that, but I haven't seen a actual Podman engine yet. Oh, well, I take that back. Like OpenShift uses Podman in Kubernetes.
Gotcha. Right. So maybe I was hearing it from them because there's a few people in RockDev who actually work on OpenShift. And of course, Matt last week worked at Paychex. They're a big user of OpenShift, so I'll blame all of them.